Actually, in the last class, I said mascarpone. Nice little mascarpone there. Yeah. Pessimist.
There's no mascarpone. How many calories?
Yeah, there we go. Calories. I'm on a diet. I can't eat that. Okay. Sugar-free.
Is it gluten-free?
Pessimist. It's sugar-free.
It's not sugar-free.
Okay. What we're looking at within this, well, sorry, I needed to put in my thing here. What does the scientist see in this?
3.141.
How can you make oxygen out of it?
How can it explode?
Well, there is sugar in it, so how can you make oxygen out of it?
So, and depending on what level of science, we might start looking at the composition within it. But there's an underlying concept behind that. Why do I care what's in it? Why do I care that there's strawberries? Why do I care that there's sugars? Okay. Knowledge for the sake of knowledge on itself is something that we rarely ever evaluate. And most scientists aren't doing that. What are they actually doing? They're trying to figure out what it's composed of and then saying, I can make it better. Those strawberries came from Arizona. Arizona strawberries are crap. I'm going to California during the summer where the strawberries taste better. And that's how I'm going to make my pie. Okay? Instead of using granulated white sugar, I'm going to use turbinado sugar because turbinado sugar has better flavor. Instead of using white flour, I'm going to use wheat flour because it has more flavor and it tastes awesome. Whoa, that was a mistake. I'm going to go back to the white flour and keep trying to refine it. So scientists are in this kind of bizarre, what people would think of as egotistical. Okay? But when we think of egotistical, we see it in kind of a bad context. We think that that person thinks they're up here, they're above us. And there are plenty of scientists that do that. Okay? But really it's egotistical in a different sense. It's egotistical in that I know I can make it better. Or at least I'm going to try. Okay? And they are constantly trying to make it better because they think they can do it. Can they all do it? No. And in fact, most of the time, what do scientists do? They fail abysmally. And if they get really lucky in their abysmal and utter failure, they created something useful. Okay? The fabric known as nylon, accidental discovery. Okay? Sometimes they set out to make something better. I'm trying to get into gold in this mountain, and there's too many people dying in the mines as they dig through this because they hit something, and the whole mine collapses. So what I want to be able to do is to carefully get that dirt out of the way so that I don't put miners in there until it's a little bit more secure. So how do I get that dirt out as quickly as possible? What was that?
Dynamite.
Dynamite. So I'm going to invent a chemical that has so much stored energy in it that when I put it in and then light a match next to it, it explodes. This will then blow all the dirt out of the way. Now we have access to whatever was in that dirt without risking the lives of miners. However, what did we then do with that technology?
We can apply it in many different ways.
We can apply it in different ways. And that different way that happens to be probably the most common now is in the process of trying to kill more humans. Okay? That gives scientists a really bad name. Okay? And I'm not saying scientists are always out there just trying to make the world better. There are some that are evil and geniuses and do bad things. Okay? But a lot of the discoveries that we're working with, we're trying to do some good. Okay? And then somebody else, and this is usually a bad class to say this in because you guys are all starting out and going different fields, somebody else in, say, like business says, I can market that somewhere else. I'm going to now sell it to a weapons manufacturer. So I like to blame businesses. Sorry, business people. Okay? My other favorite one to yell at is biologists. Okay? But our goal in science is just to say I can make it better. There's lots of things involved in making it better. It's figuring out what's in it. Okay? How do I change what that is to make it better? But that's what science is. Okay? Okay? So how do we go through and do that? Well, that's our scientific method. Okay? And you've probably seen a lot of these steps before. And in fact, I think the textbook elaborates exactly these steps, almost. We start with observation. And what was our point of observation? What do we do with observation?
We look and note that something has changed.
I see a poor person. Okay, I don't like poor people. So I'm going to come up with a hypothesis. That poor person is poor because they're lazy. Okay? We do that all the time. We make those judgments. And then what do? We walk away from it and we just keep those judgments. Scientists aren't allowed to keep those judgments. What do we have to then do? We have to design an experiment to test it. Okay? So we have to go out and evaluate those things. With poor people, okay, I know that's incredibly an unsensitive thing to say, but I don't know a better way to say that. Okay? That's more in kind of the social aspect. That might be your psychology class. Okay?
Economically challenged.
Economically challenged. That one's a bit of a mouthful, but that's fun. I can work with that. Okay? So I'm trying to learn something new about economically challenged people. So I've come up with a hypothesis behind that. I've now come up with an experiment, whatever that is, to test it. What would I then do with that experiment? At least according to our scientific method.
Record your results.
I could record my results. Keep going. I could look at repeatability. Keep going.
Reform the previous hypothesis.
Ooh, that's an interesting statement. Reform the previous hypothesis. In most cases, where do you end up seeing it go? To a conclusion. Natural law, a theory. Okay? That's not how science works. That's how we advertise it, but that's not how science works. Really what happens is at the end of that experiment, I realize my hypothesis was a complete and utter load of crap, or my experiment was, which means I have failed. And I go back and I restart the process. Then what happens?
You fail again.
I fail again. And I start all over. Then what happens?
You fail yet again.
I fail again. So scientists are these egotistical maniacs that are addicted to failure. Okay? That's one of the reasons why people get driven away from science, is they don't see this. Look at your textbook. It doesn't mention failure. What does it do? It says experiment, then goes to our scientific theory or our natural laws. It's a nice linear process. I start learning something, I learn it, and now I'm a master. That's exactly how I learned to walk. Okay, I was crawling, and then I attempted to walk, and now all of a sudden I was the greatest walker in my life. Okay, I have never improved on my walking abilities. That would be very unfortunate, actually. That could actually explain a lot. Okay. So what we have to do is go back to that iterative process and deal with that failure. When you look at your standard education system, we don't have you. When you fail something, what do you end up doing? You get rid of it, you hide it, we ignore it. Guess what happens with failure in science?
It needs to get published.
It doesn't get published. It gets swept under the rug, and we don't tell anybody about it. We do the exact same thing in science. So that when you come into a science class, you come in and hear about all these great people and what they did. They had an observation, they made a hypothesis, they made an experiment, and they discovered a natural law. Dun, dun, dun. That didn't happen. They made an observation, a hypothesis, an experiment, and it failed miserably. Okay? Really early on, it failed so miserably, they probably killed people. Okay? They may even died themselves. Okay? But we continued to build off of other people's failures and progress forwards, or even build off of our own failures. Okay? A lot of what the scientific community is about is trying to get information out there. And unfortunately, the only thing that we have accepted as being awesome as a class or a species is success. Scientists do not succeed. They fail miserably. Why do we have so few scientists? Because we've trained everybody else to think failure is bad. Right? Because we only tell as scientists our successes. So how do we fix that? Well, we need to tell you that they failed. We need to show you that they failed. Okay? How did they go through and do these things? How did they build on top of other knowledge? That's what we're trying to do within this class. How are we going to do it? Well, we have reading assignments. We have problem solves. When you go through and do the problem solve and you can't figure it out, you failed. Sucks. We don't like that word. But that's what it is. You failed. What should you do with that failure?
Learn.
Learn. How?
Analyze your mistakes.
You can analyze your mistakes. But I looked at this question, I have no clue what it's talking about. I have now failed. I can't analyze my mistakes because I have no clue what's written down.
Reread the material.
You could try and reread the material. Good. That's an iterative process. I assumed I could just figure it out. I couldn't, so I go back and I read the material, or I reread the material. Still didn't work.
Seek assistance.
Seek assistance. What do you mean?
Someone who's more knowledgeable in the subject.
Okay, so you could go to someone that's more knowledgeable. You could also just go to the people around you. You don't know who's more knowledgeable. One of your people or your peers in this class may know what was going on with that subject. Ask them. Okay? You don't like anybody in the class? Ask me. You don't like me? Ask a tutor in the tutoring center. You don't like them? You're starting to run out of asks at this point, by the way. Okay? Find a tutor that you can pay to tell you what's going on. Okay? Take advantage of all of those intermediate stages before you have to pay more. Okay? That's what we're trying to get you to do. Make sense? Okay. When is it really bad to fail?
And you keep repeating.
When you get exams.
So we could say if you keep doing the same failures, you look at a question like, oh, I don't know how to do this. Okay? You eventually figure it out, you move on to the next question, you go, oh, I don't know how to do this. And you give up again. Okay? You're repeating your failures. You have to go back out and figure out how you improved. What did you need to do to figure out that answer? Okay? So don't repeat the same mistakes, which will become important when we talk about exam 1, which I think I heard somebody mention as another place for bad places to fail. Don't fail on the exam. Okay? Don't test yourself on an exam. Test yourself in the homework. That's the point of the homework. Push yourself to find where you fail. Start fixing that. Don't fix the stuff. Go look at, oh, I totally understand observation. That was easy. I'm done. There's a bunch of other stuff on that list. Right? Find your failures, roll in them, glorify them, fix them. Okay? Is that depressing? You should say, no, that's not depressing. That's a good thing. I'm actually trying to train you to move forward. It's a good thing. Okay? So let's look at some scientists. Chemistry. You talk to a physicist, a mathematician, chemist, biologist, even an engineer. Guess what they all say they do in their grand scheme of science? They are the bridge that connects the world to theory. Guess what chemists think they are?
The bridge.
The bridge that connects the world to theory. We all think that, okay? So we all come up with our own different spins on this. You can clearly tell where my line is, okay? Mathematics and physics is our theory, and then biology and other stuff is the real world. I'm a little bit more rooted in the theory than I am in the other stuff, okay? Chemistry does that bridging through a variety of different fields. Organic chemistry, biochemistry, inorganic chemistry, physical chemistry. They're all on different parts of that depending on what they're trying to do. Physical chemistry, guess what? Bridges more on the theoretical side of it because it has the word, does it? Yes? Physics in it. Okay? But it's now applied physics to chemistry. Okay? Inorganic is kind of a step further on down to that application line. Organic, I would argue, is the ultimate bridge. It's what connects everything together. Remember how we said scientists were egotistical? Yeah? And that all scientists thought they were the bridge? Guess what my field of choice is?
Chemistry.
Organic chemistry. Yeah, I'm the dead center of it. Of course I'm the bridge. Okay. Biochemistry is now one step further on towards the biology stuff because, of course, it says bio in it. Okay. So we can use biochemistry to explain those larger, broader observations being made in biology. Okay? What part do you care about? Well, that depends. If you're just trying to stab a needle into somebody, do you need to know that the chemical inside that is made up of 25 different bonds of varying polarities, okay, with these different atoms? Probably not. Probably what you need to know is, where does that needle go? Okay? Do you just jam that in the eyeball? Like, I've never had to inject somebody. Do I just take the needle and just punch them in the eye and then inject? Does that work? Okay. Depending on what we're looking at, well, they did that in a show, didn't they? Wasn't that Luke Cage? Didn't they do that? Okay. Depending on what we're trying to do, we need varying levels of knowledge. So when you're looking at all of your prerequisite classes, it's not the content, it's the process that you're trying to learn. It is that iterative process of accepting failure and moving forward. And for those of you going into any kind of medical field, because I'm going to guess there's a significant portion of you, you're like, well, failure's not a big deal. Okay? I can fail exams, and you will probably feel like crap. What happens when your first patient dies?
It's nature.
There's a reason I'm not a doctor in any kind of health field. I can't deal with that. Okay? And I would argue that there's probably a significant portion of you that could do that. Okay? My hat's off to you. I will deal with failing exams. Okay? But I can't deal with working on someone and them dying. That's not fun to me. Okay? It's probably not fun to you either, but you've learned to deal with it. You come up with mechanisms to get through that failure. Okay? So, chapter 3. We jump around a little bit. Okay? Two big things that come out of chapter 3. Talking about matter and making observations about matter in chapter 3. Okay, so we have these two categories, qualitative and quantitative. Well, what are they? How many of you have the Webster-Merriam definition for these? That's the name of a dictionary, right? Mm-hmm. Nobody does. Okay, let's try it this way. Show of hands, who knows? You know the Webster-Merriam definitions?
Oh, I'm very talking about these words.
Up for those words.
No, not the actual definition.
Ah, okay, so what do we actually want out of this? Do we want the raw definition? No, we want the meaning. What are they intending to recognize and acknowledge? Okay. 15, right? 11:15? Okay. So what are we looking for? I got on one hand here first. Which one do you want to do? Qualitative or quantitative? Pick one. Yeah.
Quantitative.
Okay.
So obviously, I recognize like the word quantity. It resembles that quantitative. So I'm assuming it's going to be something numerical.
Okay. Use the word first, which I'm going to address what I mean by that in a second. Okay. There's this word that we say obviously. Not everything is obvious to everybody. Okay. I use it too. I apologize. Okay. But just be kind of aware of that. Not everybody knows everything. What you happen to remember, did you do any kind of Latin root studies, something like that? No. How'd you know that?
I mean,
You just compared words?
No, I've used the word before.
Oh, okay. Well, that's cheating. Numerical, yeah. A quantitative measurement is going to involve some kind of numerical value. Okay? We're going to elaborate on that in a second, but then first, sir, I believe you had your hand up as well. Can you do qualitative?
Sure. That's focusing on not the numbers, but how they're important to the meaning of the thing.
How good it is.
The quality.
Right. Their qualities, their bits and pieces.
So if I was to say there were two sheep in that picture, the two would be what? Qualitative or quantitative? Sheep would be? If I just said there were two in that picture, is that a quantitative use to anybody? No. No. So when we look at the quantitative measurements, yes, the number is important. Okay? So everybody in this class gets 2. Out of 100, you just failed. That's not good. What's our unit? What are we comparing? What are we looking at? So when we're thinking about quantitative, it is numerical in nature, but it also needs to define a unit, something attached to it. Okay? That is what that species is. If I now say those 2 sheep are fuzzy, what is fuzzy? That's the qualitative aspect. 2 sheep, touche. Okay? That is our qualitative observation on it. It's kind of a, oh, thank you. Kind of that touchy-feely aspect is what I would look at it as. Which is more important, qualitative or quantitative? Ooh, it was a loaded question. It depends what you're looking at. Okay? We see lots of people saying, oh, quantitative is going to be the most important part of science. Okay? There are 2 sheep that will headbutt you anytime you are within 5 feet of them. That headbutting aspect is kind of an important thing if you were to say walk near those sheep. But that's not a quantitative measurement, that's a qualitative one. Okay? So when we're thinking about these, we have to recognize that they are both useful, but in different situations. Which means when we go through and take notes, say in a lab environment, we need to be observing both. I do want to know the quantity of each of the chemicals I'm working with, but I also want to know something about their color, okay, or their phase. Okay, why? What if the experiment fails? I can now go back and talk to somebody and say, well, I was mixing water with salt and it exploded. Well, that shouldn't have happened. I was told that that shouldn't happen. So, well, what did those things look like? Well, the water was this black liquid, and the salt was this orange powder. Those aren't standard colors for those species. Are you sure you actually mixed water and salt? Oh, maybe not. Maybe I mixed a couple other things. So those qualitative observations can help us recognize failures and learn from them if we've made those observations. If we haven't made them, we can't do anything with it. We'll pick up there on Monday.